All right, D13 notes, graphing rational functions, a general case. When graphing these, there's a few characteristics we need to make sure we graph. The key features are going to be asymptotes, vertical, horizontal, oblique, which we'll see later, and then our intercepts, x-intercepts and y-intercepts. Also, holes in the graph, which we'll see in the next section. You have this document as well, where Rady is used to help break it down. Personally, I'm not a huge fan of Rady. Um, you'll have this document to go over if you wish. The pre-written notes that are on the Google class are completed using Rady. But again, however, I'm going to do it slightly differently because it's not. I think Rady is a bit more complicated than it has to be. You need your intercepts, so x-intercepts. So set it equal to 0 and solve it. This is when your function is equal to 0, solve for x. Your y-intercept is when you plug in 0 and calculate the y-coordinate. They may have one, they may not. It just depends on the graph. Other than that, we'll have our asymptotes. You'll have your vertical asymptotes, which occur when the bottom is equal to 0 and the factor does not cancel when simplified. So we have vertical asymptotes. Let me go ahead and write the word out. And for this section, we'll have horizontal asymptotes. Again, the next section we'll talk about holes and different types. All right. So let's go through some of these examples and we'll locate these key features. All right, so number 1, my intercepts. So my y-intercept, let's go ahead and calculate that. Plug in 0. So we plug in 0, we end up with 0 over 3 or just 0. So we have a y-intercept at 0, 0. There's one key feature. Let's go ahead and plot that. X-intercept. So that's when you set it equal to 0 and solve. So I set this function equal to 0. So it's when this is 0, I want to find the x. And we start solving these. Step 1 is always going to be to multiply your denominator out. So this would cancel here, and you'll always be left with just your numerator equal to 0. So for your x-intercepts, the shortcut is just take your numerator, set it equal to 0, and solve it. And this one's 0, which we determined already from the y-intercept. There may be multiple x-intercepts. In this case, there's just one. All right, what else? Asymptotes. All right, so we have our vertical asymptotes. To solve that, you set your denominator equal to 0 and solve for x. If it's quadratic, you'll have 2 of them. So depending on what the denominator is, you can have multiple vertical asymptotes. So at -3, we have a vertical asymptote. Let me extend this a bit more. All right, horizontal asymptotes. All right, so that one requires a bit of work. I'm going to go back to the other document. So roots, so we'll just talk through this real quick. Set the numerator equal to 0, solve as we discussed. Vertical asymptote, set the denominator equal to 0, as discussed. T squared, I'll come back to that. I'll discuss that shortly. And behavior. So this is what we're looking for our asymptotes at the end of the graph. So as x gets really, really large, what is the y approaching? On the left side, as x gets really, really small, what is the y approaching? That's what we're discussing here. All right, for this section, there's going to be 3 cases. So, case 1, case 2, case 3. All right, I'm going to start with case 3 first. Bottom heavy. If your denominator has a greater degree than your numerator, you'll have a horizontal asymptote at y equal to 0, the x-axis. So this one here, 1x to the 0 power. The degree of your numerator is 0, degree of your denominator is 1. This one here, if you recall, guys, x to the 0 is just 1. Degree of the numerator is 0, degree of your denominator is 2, so the bottom has a greater degree. Can also be something like x plus 1 over x squared minus 3x. So degree of your numerator in this example is 1, degree of your denominator is 2. So if the degree of your denominator is larger, you have a horizontal asymptote at y equals 0. All right, let's go to case 1, where it's a balance. So this one is referring to the degree of your numerator and denominator being the same. So for example, say we had 3x to the 4th power, x squared minus 8, 2x to the 4th power minus 7. So for this one, the degree of your numerator is 4. The degree of your denominator is also 4. If the degrees match, you have a horizontal asymptote at the line y equal to the ratio of the leading coefficients. So 3 over 2. So the line y equal to 3/2 is where you have your horizontal asymptote. So as x will get really, really, really large, plug in a billion, trillion, and so forth, the y coordinate will get closer and closer to 3/2. Same thing on the other end, if you plug in very small numbers. All right, this middle case here, top heavy, plug in. All right, let's look at the second case. I apologize, that was my son jumping in and asking about the moon. Oblique asymptote. So in this case, it's going to be a slant asymptote. We'll talk about that in more detail in the next section. That occurs when the degree of the numerator is 1 larger than the degree of the denominator. So it's top heavy. In this case, there is no horizontal asymptote. And we will do long division or synthetic division to find the asymptote. So this one, there is no horizontal one. So this one will be something like x to the 5th over x squared plus 1. So those are the 3 cases. The bottom is bigger, it's y equal to 0. If they have the same degree, it's the ratio of the coefficients. And if the top is larger, there is no horizontal asymptote. Let's go back. So this one here, the degree of the numerator is 1. The degree of your denominator is also 1. Okay. My leading coefficients are 1 for the numerator and 1 for the denominator. So the horizontal asymptote is the line y equal to the ratio of those 1 over 1, or just 1. So there's your horizontal asymptote right there. It got shifted up 1. Okay, there's no holes in the graph, which we'll discuss in much more detail in the next section. But for right now, I'm just going to put none. Let me talk about it real quick. If we had x plus 3 up top, and it caused that to cancel, then this negative 3 would be the x coordinate of where the hole in the graph existed. You would plug back in to determine the y coordinate of that hole. All right, other than this, few key points, your choice to kind of see what's happening. So I'm going to plug in -2, -3, -4. So I'm going to plug in numbers right around the vertical asymptote. So I plug in -2, we get -2 up top over 1, so -2 right here. I plug in -4, you get -4 up top, -1 on the bottom, so 4, 2, 3, 4. So we're right here. Plug in really large numbers, say 100 or whatnot. I'm just gonna go with 10. I plug in something out here. Let's see what happens. We end up with 10 over 13. And the larger the number you plug in, the closer this fraction will get to equaling 1. 10 over 13 is some decimal, but it's getting closer to 1. All right. As x gets really large, it gets closer to 1. As x gets closer to -3, we end up with negative values, -100 billion, and so forth, approaching the vertical asymptote. On the other end, let's plug in -10. We would have -10 over -7, so positive 10 sevenths. So this one will approach 1 on the other side. So as x gets really small, the graph gets closer and closer to this horizontal asymptote. And as x gets really close to -3 from the left, your outputs will get larger and larger. If you look back to this page here, this t part, let's find it. If a factor is squared, that's going to tell you a few key things. If a factor is squared and that gives you your x-intercepts, it would have been tangent and not have gone through it. So for example, had this been squared, or any even power, it would have touched 0, 0 and returned something like that instead of going through it. If the denominator or the factor that gave you your vertical asymptote is an even power, then your graphs will approach that asymptote in the same direction, both up or both down. We did not have that in this case, so the graph approaches a vertical asymptote in opposite directions. But if you just plug in a few key points, you will see what's happening and which way the graph is approaching it. Any other points are up to you. The main thing are intercepts and asymptotes. Holds, you'll see next time. A few other things. One more bit of information. Your horizontal asymptote, will the graph cross it? Not on this section, but it is possible. And to determine that, you would set it equal to that horizontal asymptote, and you would try to solve for x. This one, if you try to solve for x, you would get 0 equal to 3, which is not true. So our assumption here is false. So it would never cross the horizontal asymptote because of that. So that's number 1. I'm going to stop the video there on this for this one and continue with the other examples on the next video.